Hello and welcome back. Let's look at one final system of inequalities in section 5.5. We've got three inequalities, so this is x plus y is less than 2, negative 2 is less than or equal to x, which is also less than 1, and y is less than 3. So let's just go in order and let's graph each of these. So x plus y is less than 2. So in order to graph this, we want x plus y is equal to 2. We'll replace the inequality with an equal sign. And if I solve for y here, we get negative x plus 2. So when we graph this, our intercept is going to be at plus 2. Our slope is negative 1, so we're coming down. And in fact, because this is just strictly less than 2, we will have a dotted line here to indicate we don't want to include these points in our solution. And we use my favorite point here, 0, 0, to see is 0, 0 included in the solution set to this, or is it the opposite side of our line? Well, if I plug 0 and 0 into there, so 0 plus 0, 0 plus 0 is 0, and 0 is less than 2. So it is in our solution. So for this first inequality, that's all of the points below this dotted line. Now let's look at the second inequality, because it actually is two inequalities in one. We have negative 2 is less than x, which is less than 1. This, we can interpret this as two different inequalities at the same time. So we have negative 2 is less than x, and x is less than 1. So both of these need to be true in order for this next one to be true. So this is where we can draw our lines here. So when x is equal, so let's graph these. When negative 2 is equal to x, and when x is equal to 1. So when x is equal to negative 2, that is this line over here, and we have a less than or equal to. And we know, so because negative 2 is less than x, that means that we're looking at x's that are bigger than negative 2, which should be all of the x's on this side. Let me do this in one continuous. So that's all of the x's over here. Now at the same time, we also have x is equal to 1. And this is less than 1. So this is going to be a dotted line here. And if x is less than 1, we are looking at all of the x's to the left of 1. So where we want is where our things overlap. So right now this is a bit of a mess. So let's draw this in. We want everything to the right of negative 2, because x is greater than negative 2, and everything to the left of 1. Well, that's this little band right in the middle. So this is where x is going to be greater than or equal to 2, but less than 1. The final inequality here is y is greater than 3. So we want to graph when y is equal to 3. So let's draw a little one here. So we have y is greater than 3. So we will have a dotted line. Oh, oops! I want to make this a little bit bigger, don't I? 1, 2, 3, 4. 1, 2, 3, 4. So our line y is equal to 3 is when the height is equal to 3, and because it was y is greater than 3, we will have this line right here, and because it's greater than 3, we will have everything above this line. Okay. So we have our three regions. We have between x is negative 1 and x is 1. X is negative 2 and x is 1. We have everything above y is equal to 3, but everything below this line here. So let's graph this. So we have the line y is equal to 3. It was a dotted line, or dashed line. I suppose it doesn't matter. We have the line x is equal to 1. And the line x is equal to -2. And we have the line y is equal to -x plus 2. And that was the dotted line. Cool. So we have all of our regions, and now we want anything between these two lines, between the two vertical lines. So we are looking at things in here. However, we are only looking at things above this line, while at the same time below the diagonal line. So below the diagonal line but above this line, and in between those two lines, it's only this little triangle up here. So when all is said and done, we just have this itty-bitty little area there, and that's it. So any point that we could find inside of here should satisfy all three of our inequalities. Any point outside of here, from anywhere outside of there, should not satisfy those inequalities. And there you have it. We've finished graphing inequalities.